Good morning. Welcome to another day of science. It is Wednesday. Yes, it is Wednesday. It's Wednesday, January 13th. This is your Wednesday walkthrough video. All right, let's take a look at what we got going on for the Wednesday, Thursday folder. First, I appreciate everyone who's just been starting off the return to school strong. Had a good week last week of review. This week has been good review. A big heads up, Google Meet on Thursday, 11:30 to 11:45. I'll give you some more specifics about the final exam and that sort of stuff. So tune in for that. It will be must-see TV or Google Meet, whatever you want to call it. All right. Anyway, so the Wednesday, Thursday folder. Watch the Wednesday walkthrough video. Thursday, there will be a Thursday walkthrough video. We have 2 pages to go over review stuff. I put a lot in these pages just because I want to make sure we're reviewing all that stuff from all the first 9 weeks, and especially that beginning of the second 9-week stuff. It's been a minute since, early November. It was a couple months ago, so I want to make sure we recover all that stuff. And then there will be a quick check, and that will be open on Thursday once we've had a couple days to go through the review stuff. All right. So in the Wednesday, Thursday folder, the first page for review will be about chemical bonds and layers of the Earth, and then a Pangea and plate boundaries review page. So let's look at this first one here. This sort of wraps up what we talked about in chemistry. Talking about chemical bonds. So things to keep in mind here. When 2 elements bond of 2 atoms of different elements, that forms a compound. And when we form a compound, those bonds there's just different types of bonds as far as how they create a new substance, how they create a new compound. All right. The other thing to keep in mind that when atoms bond with each other, it's the outside electrons. Only the electrons that are in the outside layer, they're the only ones that do the bonding. All right, and those electrons that are in the outside layer, those are called valence electrons. So these are a couple of vocab words that might show up on the quick check and also might show up on the exam. So keep that in mind. Then we had 2 types of bonds that we talked about. An ionic bond was the first one, and that is between a metal and a non-metal. So when you're looking at the periodic table, you find, and I say, okay, what are the 2, and I give you 2 elements that are involved in a bond. You need to look them up on the periodic table. If one's a metal and one's a non-metal, you know you've got yourself an ionic bond. So NaCl, which is sodium chloride, better known as salt, that is an ionic bond. This is calcium sulfide. That is an ionic bond. Magnesium chloride, another ionic bond, because sodium, calcium, magnesium, those are all nonmetals. Chlorine, sulfur, and chlorine again, those are all nonmetals. Sorry, sodium, calcium, and magnesium are metals. I don't know if I said that wrong. And then, so it's a metal and a nonmetal, and then when we have an ionic bond, the electrons, the valence electrons, are actually transferred from the metal to the nonmetal. So sodium starts out looking like this. It's 3 rings in the electron shell, and it has 2, 8, and then 1. And chlorine has 2, 8, and then 7. Chlorine wants to get to 8. So sodium, when they bond, it literally gives up its electron to chlorine. So now sodium has 8 in its outer shell, and chlorine also has 8 in its outer shell. So they're both what we would call a happy atom. So in ionic bond, electrons are literally transferred, not shared, they're transferred. This one, sodium gets rid of it and gives it to chlorine. So the metal gives electrons to the nonmetal. All right. Covalent bonds, this is when 2 nonmetals are involved in a chemical bond. So when you look them up, when I give you elements that are involved in the bond, you have to look them up in the periodic table. If they're 2 nonmetals, then it's a covalent bond. And in this situation, electrons are shared with one another. So carbon and hydrogen, when they bond, the hydrogen shares its 1 electron with the carbon. It's not getting rid of it, it's just sharing it with each other. All right. Next thing we jumped in and talked about after chemistry, we started getting into like earth science, plate tectonics, that sort of stuff. So we first started off by looking at layers of the earth. The layers of the earth that we are concerned about is the crust, continental crust, and oceanic crust. There's two types. Continental crust, as you can see, is much thicker than oceanic crust. And the other thing to keep in mind is that oceanic crust is more dense than continental crust, so that when those two types of crust collide, the oceanic crust gets pushed underneath the continental crust. And that has some big implications for plate boundaries later on, because that could form like volcanoes and trenches and stuff like that. The asthenosphere, this is the layer that the crust plates sort of float on, and it moves very, very slowly, kind of like silly putty. That allows the plates to move around. Then we have the mantle, the thickest layer in the earth. And the analogy that we used for the mantle was like a lava lamp, a slow motion lava lamp, where the hot material is rising and the cold material sinks back down. And sort of it's moving heat from the core outwards to the crust. So when you think of mantle, think of lava lamp. Then we have outer core and inner core. Outer core is hot and liquid, very, very hot. And some of that liquid bubbles up, can become magma, and comes up and creates hot spots and stuff like that. And then the inner core is even hotter than the outer core, but it is solid because it's very, very dense. The pressure is incredibly intense down there. So those are the layers of the earth. The other review page, which you can do it today if you want to, or you can save it till Thursday. Reviewing the Pangea. There's 2 slideshows I'd like you to go through, and then we just sort of a recap on plate boundaries. The slideshows talking about Pangea, trying to prove the existence of Pangea. Idea first proposed by Alfred Wegener in 1912, and he said that all of the continents were at one time connected together. He said it looked kind of like this. You guys can zoom in on your own computers, be a little bit easier to see. You can kind of see the outlines of the present day continents on there. So he proposed this idea, but people didn't believe him because he didn't have evidence. You need evidence. If you're trying, I kind of used the analogy of like, let's say you said someone committed a crime, but you don't have any evidence. You got to collect some evidence. So that's what Alfred Wegener did. He found a lot of evidence. 1, he said the continents fit together like a puzzle. That's evidence, not proof. 2, he said that there were fossils on identical kinds of fossils on continents that are now separated by oceans. And he said the only way these fossils could be found on the same continents is that if at one point they were all connected. So that was a good piece of evidence. Rock evidence. He said if you look at the east coast of the United States and like the west coast of Africa and Europe, same exact types of rocks, same exact ages of rocks. The only way for those things to happen, he said, was for them to form at the same time and place, meaning that the continents were once connected. Again, another piece of evidence. And the 4th piece was that glaciers, there's evidence of ancient glaciers on continents where there are no glaciers these days. And even during ice ages, it would have been impossible. Like here's India and Africa and stuff. Like they're very close to the equator. Even in a bad ice age, they would not get glaciers. So those were his 4 pieces of evidence. The next slideshow, we talked about, well, if he had all this evidence, why didn't people believe him? That's what this slideshow talks about. Because they didn't believe him, because he did not have any proof. Even if you got a good case against somebody in a court of law, hey, he stole my car or whatever, you still need to have some proof. All right, so he was missing proof. Unfortunately, Wegener died before proof was discovered. Scientists did eventually find some proof. A large mountain range was discovered going the entire length of the Atlantic Ocean, and upon further study of that ocean, we realized that new crust was being formed there, and that was pushing the plates, moving the plates. So here's the mid-ocean ridge. New magma bubbles up, lava bubbles up. It pushes the old stuff out of the way, and that is moving the plates. And we can see these mid-ocean ridges all around Atlantic, Indian Ocean, Pacific Ocean, creating new crust moving plates around. And discovering the different ages of rocks. The further you get away from these mid-ocean ridges, the older the rocks get, meaning, yes, they have in fact moved the plates. So later, after Wegener died, there was proof that the plates are moving. So his idea, even though people laughed at him originally, was eventually proven correct. And the last thing, plate boundaries. So the three different types of plate boundaries: divergent boundaries, as we just said, are when two tectonic plates are moving apart from each other. New crust is created here, and it pushes the new plates, the plates in opposite directions. Then we have convergent boundaries, and when we have convergent boundaries, you can have different types of convergent boundaries. You can have continent to continent plates colliding. Anytime there's a convergent boundary, they're coming together, they're colliding. So when two continental plates collide, it creates mountain ranges, like the Himalaya Mountains in India. You can have ocean to continent convergent boundary. When this happens, you create volcanoes on land that already exist, like volcanoes on existing continents. So like all the volcanoes on the Andes Mountains in South America, or the volcanoes that are out in Washington State and Oregon, they were formed by oceanic to continental convergence. You can also have ocean to ocean convergent boundaries. And when these happens, you get very deep ocean trenches and then volcanic islands. So all the islands that are up there off the coast of Alaska, those are all ocean to ocean convergent boundaries. Lots of little tiny islands with their own little volcanoes on them up by Alaska. Same things over like Japan and the Philippines. Those are formed from ocean to ocean convergent boundaries. And then the other type is a transform boundary. And this is where two plates are sliding past each other. One plate's moving one direction, the other plate's moving in another direction. They're not moving towards or away from each other. They're just sort of sliding past each other. Great example of this is the San Andreas Fault out in California. And typically at these places, we get lots of earthquakes. And if you know anything about California, it's known for the earthquakes. All right, kind of a long video today because I wanted to go through all that review stuff with you. But that is, yes, that is the review pages for, Wednesday, Thursday, and then Thursday the quick check will be open for you guys to take. And don't forget, Thursday we have a Google Meet, just sort of go over this stuff and to go over final preparation for the final exam. As always, let me know if you have any questions. Keep getting missing assignments turned in. We're getting some. We're getting there. We're making progress. I appreciate that. People are starting to feel the crunch of the end of the semester coming up. So getting missing stuff turned in. I had one student turn in 5 or 6 yesterday. Shout out to him. He knows who he is. I appreciate that. Keep it up. Keep it going. All right. So have a wonderful day. Let me know if you have any questions. Good luck. Bobolik out.